So definitions, we're going to start with this right here. So the theoretical probability is the likeness, we're going to say the likelihood of an event. So we're going to say the likelihood of an event. Let me spell that right. L-I-K...
L-I-K-E-L-Y.
Yeah. Of an event happening based on all possible outcomes. Bless you. Okay. Okay, the next one is experimental probability. Is the ratio of an amount of times an even occurred to the total number of trials. So that's just saying the ratio of the amount of times that something occurred. I'm just going to say of that something occurred to the total number of trials. Okay, independent event. Okay, is the outcome of one event that does not affect another event. Okay, and then dependent events is the outcome of an event that does affect the outcome of another. Okay, so possible combinations. So we're going to go on the second piece right here. It says, list all the possible combinations of tossing a coin, rolling a die, and spinning an equal section color spinner, red or blue. So we're going to list all the possible, so that's just writing them out. So we're going to do some shortcuts. We're going to say heads and tails for the coin. Rolling a die is 1 through 6. And then spinning an equal section of red or blue. So you're going to say heads, 1, red, right? And then how are you going to do the next one? Heads, 2, red. Heads, 3, red. Okay. Are y'all good with that? Now, what would be the next one? I would say heads, 1, blue. Does that make sense? all the way to heads 6 blue. And you can do tails 1 red, oh man, I wrote 4 twice. Okay. Any other options you think you might have? Okay, so we're listing, this is a list version, right? Okay, so can we draw it as a tree? What would we do? Heads first and then tails over here? And then what would be your options? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm not a good. And then from here it would be 1. And then from here it would be red or blue, right? Oh, sorry. And then it'll be red or blue. It'll come to you. Just gonna drop it. Okay. I'm gonna connect it through the screen right here. Sorry. Okay, so 1, 2, 3, 4, 5, 6, and then red, blue on every one of those. Bless you.
There's something in here, I swear. I was fine, though. I got that in here.
It's the kids.
It's us.
Okay, so that's the tree version, okay?
Dude.
Don't die.
Okay, y'all ready? Okay, so going back to the flipping to the other side. So we're going to start at the examples and we're going to start the very base page. And it says if a bag contained 4 red, 3 black, 2 orange, and 4 blue, what is the probability Greg drew a red marble, did not replace it, then drew an orange marble? Okay, so the first one, the red marble. How many marbles do we have total? We're working with 2 things here. A red marble first and then a orange. How about orange? Okay, so red is 4, 3, 7, 8, 9, 10, 11, 12, 13. So there's 13 total marbles, right? When we very first start. Now, the red option is 4 out of 13. Do y'all agree with that? Yes. Okay. Now, he did not replace it as the key words right there. If he did not replace it, that means we have 12 left in the next one. Okay. So, and then how many are orange? 2. Okay. So, we're going to multiply these 2 fractions. I'm going to cross reduce because it's easier. 4 and 12 are both divisible by 4. Okay. So, 1 and 3. 1 times 2. Then we multiply straight across. 13 times 3 is 39. So I'm going to find the probability, cross reduce. Maybe I need to say find the probability of each. Cross reduce, multiply straight across. Okay? So look at our next one. Oops, I went too far. Sorry. Okay, donuts are provided for the students at morning student council meetings. If the box contains 3 chocolate, 5 glaze, and 4 sprinkle, what is the probability of Sam selecting a chocolate donut without looking? Okay, well, how many donuts are there total? 3, 8, 12. Okay, so chocolate donuts, 3. Reduce this to 1/4. There's only one thing happening, so we don't need to multiply. When there's more than one thing happening, you're generally going to multiply. Okay, you're going to multiply because it's a probability of this, then that. Okay, next one. Carrie is performing an experiment in math class. She tosses a coin and spins an equally divided 4-color spinner, red, yellow, blue, green. What is the probability of her spinning a red and a coin landing on tails? Okay, so red first. How many options are there? 1, 2, 3, 4. How many are red? What? 1. Okay, and then the coin. What are we wanting? Tails, which is 1 out of 2. So you find the probability of each, and then you multiply it, and you're going to get 1/8. Oops, sorry, couldn't see that. And then my last one says, Jackie is selecting an outfit for school. He has 3 t-shirts, 2 sweatshirts, 2 pair of wind pants, and 3 jeans. How many combinations of tops and bottoms does he have to choose from? Okay, so how many? We have 3 times 2 times 2 times 3. So 3 times 2 is 6. 6 times 2 is 12. 12 times 3 is 36. He could create 36 different outfits from that amount of clothes. Okay? So you could wear this shirt and this jeans. However, this shirt, this sweatshirt, this wind pant, this jeans. Does that make sense? So he can create...
Ties, shirts, pants one time. There's like almost 2,000 combinations.
You could probably do that. You could go in your closet and see how many combinations you could come up with, okay? So that should be fill out this, okay? So make sure that is totally filled out front to back.
Like and subscribe. Click the bell.